not safe, that's not efficient in terms of energy saving perspective. Like it is said that produce one Bitcoin, you need an amount of electricity that is needed to power into one house with one family. So it's 2 Bitcoins, 2 houses, and so effectively you just burn the gas, you burn the oil, you burn the source of power just in order to do this electronic money, like Bitcoin. And the same applies to Ethereum at the same time, but Ethereum is going to move to the proof of stake in some future, but we'll talk about proof of stake later. Another problem with proof of work is that even if I have enough power on my particular computer, there is still a low probability that I will be able to control many of transactions in the network. So there is a trend in Bitcoin community that miners, individual miners who is capable for mining new Bitcoins and solving cryptographical problems in order to blocks, they cooperate in pools. So somehow, so each of us in this room may have their own hardware to mine Bitcoins, but we agree that we share this work. We agree that we share our computing power in order to come up with solutions to cryptographical problems suggested by networks faster than, say, someone alone sitting in their home somewhere. And so, if we coordinate, then our community has more impact, has more chance and more probability to impact on the history of the blocks than any particular individual. And the real history is that in Bitcoin, for example, there are just 4 pools of miners who own more than 50% of Bitcoin network, and all these 4 pools of miners are located in China. And if we think that maybe all these China are actually coordinated by the same people in Chinese government, then we can assume that at some point Chinese government is capable to have more control on entire Bitcoin than United States government has impact on the US dollar. So there is a way, so the Bitcoin is not energetically safe, and Bitcoin is not actually safe, and it doesn't prevent network from being managed from someone who has a lot of computing power. So now that's why more and more companies are looking to more energetically saving and from some perspective more safe proof of stake. What's proof of stake? Proof of stake assumes that the probability affects your chance to create a new block depends not on amount of power that you burn, but it depends on amount of virtual cash that you own, amount of stake that you make for the whole community. And actually, and by the way, Ethereum also is moving to this direction. The proof of stake on itself also has its own problem. From an energetical perspective, it's good, it's energy saving because you need to mine the cryptocurrency in order to become the person who is authorized creation of new blocks. But you still, so you just need to have enough amount of money. However, we can imagine the following situation. Let's say that you or some people want to steal money from me, person of the community. Then let's say half of you cooperate with Eugenie, and you send your money to Eugenie for a short period of time. And for a short period of time, Eugenie owns tremendous, much greater than me or anyone else in the network. And then Eugenie has greater probability to actually change the history of transactions, and then he can steal money from me, he can create money that removes money from my account and then transfer money back to me. So there is a way that community can fool the system in this way. So, in order to solve this problem, there is what is called delegated proof of stake. So the responsibility of person to or node in the system to actually authorize transactions based not simply on the fact that it has a lot of stake. Rather, the persons are nominated manually. So there are people who decide who is the right person to authorize the transactions, and these people are selected also based on the stake. But so that makes safe. So that makes transaction saving process safe. But then that's not a purely democratic system. That's not purely distributed computing, because we have some kind of centralized management, because we manually select the best person who will share to actually sign this box in the system. And now the solution that we with our colleagues suggest to solve the problems of blockchain and other distributed systems is what we call proof of reputation consensus. The idea of proof of reputation consensus is that instead of using power or using money, we use reputation. So reputation is amount of trust or amount of rating that people give from one to another. So idea is that if, say, all of us in this room trust Eugenie and somehow deliver our votes to Eugenie, then Eugenie has more power in the system, and he has greater probability to impact on the log of transactions and in order to verify the validity of these transactions. From first glance, this kind of consensus also can be full or fake, because say half of you makes many votes to me. Like let's say someone of you create a bot which create fake accounts, and all these accounts give votes to me, and I get more reputation. But all this reputation is actually fake because it's blown by bots. And then one may say that given such reputation blown or pumped by bots, I have more authority than Eugenie because he just 10 voices, and then I can actually take over the system and get control of the system and manage and do some bad things and do some wrong transactions in respect to Eugenie and other parts of the members of the community. But if we design the reputation system right, this won't happen, because the power of vote would depend not on just the fact that I vote for someone. The power of my vote to Eugenie depends on my own reputation. And my own reputation is computed based on the reputations people are giving me. And reputations people are giving to me are also dependent on the reputations of these people. So if we create an army of fake accounts or army of bots, and even we have 1 million bots that are providing reputation to some alien person here or some intruder, then this reputation might be zero, because each of these bots has reputation equal to zero. On the other hand, if some person has reputation given just by 3 people, but each of these 3 people has reputation given by other few people with high reputation, and each of these 3 people has also reputation created by people with high reputation, then we can build hierarchical construction of reputation history, and it can be full, because in order to get a good reputation, it should take a long time, so reputation is actually created. And so that's the problem number 1 that I was going to talk. At this time, we have some kind of concept of this, what we call proof of reputation. But there are 2 things needed. First of all, someone needs to make some mathematical foundation of this idea. Right now, it's just written as idea that's simple, but there is a way to make mathematical provement that this design is better than design of proof of reputation or than design of proof of stake or proof of work. And the other side of this problem is that someone may do just simulation, like create a model of blockchain system or distributed processing system, and do simulation of proof of work, do simulation proof of stake, do simulation proof of reputation, and model attack to introduce some fake transactions or take over the control of the system in the system, and then prove experimentally that this kind of reputation has more reliability and provides more protection against these attacks. So that's, and if this work succeeds, it could have good applications for the projects I'm working with, and also some other projects in blockchain domain that are on the market in Russia and abroad now. Okay. So, any questions on this part or moving further? Theoretically, if we can make bots grow in the same hierarchy, but first of all, this will take time. Like, in order to have hierarchy of bots to the same extent as hierarchy of real users, that these bots should start growing hierarchy nearly at the same time as humans. It should be comparable time. Like, the network is created, the people are started to make transactions, this history is accumulated, and at the same time, the bots should be starting to prepare themselves to attack and to take over of the network at some distant point in the future. That's one point. And another point is it is assumed that originally the network is created by humans. And the first transactions in the network that are made in this network are made by humans. And these humans are trustable, because otherwise there would be no point for creating this network. So it is assumed that if the history like in the history of Ethereum, it is known that at some point when there was problem with actual takeover of the network, and there was just decision by one person and who actually made his followers to follow him, and the Ethereum was split. So now there are two Ethereums. And followers of one Ethereum are blaming the followers of the another Ethereum, and the followers of the first Ethereum are blaming followers of the other Ethereum. So that there was one person. On the other side, you can imagine a situation that there is a person who created network, but eventually he is not participating in its work. And there may be other people appearing in this network, but these people were authorized by the original person. So this person on itself, on herself, or on himself won't have high reputation in the network. It's in some point of the future. But there may be other people somehow given authority from this original person. So there are many questions to discuss in this study.
There's a problem with combinatorial algorithms and pattern recognition, because when you run a code, code always, this kind of codes, they work on random generations, but it can impact your algorithm for some time. But after that, if you use combinatorial algorithms and pattern recognition theorem, maybe you can, of course, it will hamper your algorithm for a period of time, but after that, maybe you will be able to tackle it. Because a real populated flow of information and a bot information can be differentiated using the pattern recognition. Every code has a pattern.
Yes, that's another story. That's actually it's here about the patterns. We move to another question, but one of another direction of this work is being able to detect what is called reputation rings. Like we create, there could be situations when I provide more reputation to Eugenie, and he is providing more reputation to me, and we are somehow pumping up our reputations. And system can detect it easily, but we can create a ring. Like I give reputation to Eugene, and Eugene gives reputation to you, and you make reputation to me, and we are somehow pumping the reputation in the ring. And the rings may be larger. So one of the problems that potentially may be needed to solve in this system are detection of such reputation rings.
So these rings are bot made, or are they like real?
Either way.
If they're bot made, then if you don't change the code very often, maybe you have a code over a code that wraps it and changes it very often. If you don't have it, you can recognize it maybe after some time.
Yes.
As I said, it will hamper your growth for some time because it's a code and it's a new one in the market. But if you use some code which has like a power to recognize some kind of pattern,
yes. Fraud detection. The problem of fraud detection still present here. So it is present here. It is present here. It is present in conventional banking systems.
All I want to say is the real human information population. If the information is populated by a real human being, it doesn't have any pattern. It always changes.
Okay.
How can you have a pattern because as per the cognitive theories in the cognitive sciences, every building has its own mind, and if you write a code, it is like systematic. But a bot code is systematic. But if there are a lot of human beings around, how can you pull out a real it can be differentiated from the code pattern. So you can use combinatorial mathematical models.
Okay, so what's the point? So what's the question and what's the suggestion?
The question was, the guy asked that how can you differentiate the bot if the information is populated by the bot and the information which is populated by the real human being. I said that you can do it through combinatorial mathematics.
That's another story. If we are talking about the behavioral patterns of the members in the society, that's just another story.
So we cannot.
It's not that easy. It's not that easy because right now bots are trying to see for example, saying that, okay, you like some person, and now this person appeared in the movie, or like you had a very pleasant conversation with that particular person, and now that person is about to have good conversation with you, or it can recommend me some news online, or it can recommend me some movies or events, public events like fairs or parties. So on one hand, agent is connected to my social networks and my social activities and communications with my friends and colleagues and in social networks. And on the other hand, it can connect myself to the information sources online. At this time, we are supporting 5 social networks. And so 3 of them are known to everyone: Facebook, Contact, Google+, and 2 others are Steemit and Golos. Steemit and Golos are social networks based on the blockchain technology. Actually, they are very similar. The only difference is that Steemit is mostly English language social network, and Golos is mostly Russian social network. And what we do in these social networks? We use the information stored there. So there is information like follower between the 2 people. So this person may be follower of that person, and that person may be follower of that person. They also people are making posts, making comments on these posts. And these posts are using words and phrases. And also these people are making likes or votes with respect to these posts and comments. Like is a term used in Facebook and Google+, and vote is used in social networks on blockchain like Steemit and Golos. And also every event like post, comment, or like, or vote, both have some timestamps. So we can somehow identify the time at which the vote or comment or text just took place. And we can apply some mathematics that we won't spend time on this now. And then we can extract more information from this. Like I can figure out what words are specific to my behavior in particular periods of times. I can figure out what's the change in my reputation during a particular period of time, whether my reputation is going up or my reputation is going down. I also can figure out which people are similar to me, who are my best friends and colleagues, who are the people that I pay attention to, like who are my opinion leaders or who are the authorities that I trust to. Also, I can figure out who are my friends and followers, who follow my posts, who comment on my posts, who create threads based on my posts, but I may be not paying attention to that. And based on that, we can infer social graphs. We can build social structures in the communities that are using these social networks. And in these social graphs, we can identify particular personalities and particular types of communication, particular communication types. Like, for example, here is a social type, a follower. Like person who doesn't say much. This person just has many authorities, many opinion leaders, and he just follows all these people. Makes comments to these posts, likes these posts, but this person doesn't contribute to the network itself. The other person, the opposite type, is social type opinion leader. This person makes a lot of posts and he has a lot of followers. And all these followers are just making comments and making likes to post to this particular person. Another social type is a peer. That's a person who has many people who actually have mutual communication to him. So each of these people has communication in the both directions. So this person is writing comments to this person, and this person is writing comments to this person. And by the way, to make it clear, on these charts or graphs, the position, the vertical position means reputation. So the people the person of interest, like primary user, is always in the middle. And people who are higher than the person of interest has greater reputation than the person in the middle. And the people who are below the person of interest, they have lower reputation. And the thickness of arrows indicates intensity of communications. And so if you consider social type here, then we see that there are a lot of people at the same level of reputation, and they have symmetric kind of communications, like I talk to you, you talk to me, so we are peers. We are not like you are authority, so I appeal to you, but you don't pay attention to me. And finally, there is social type connector. So the connector type has few authorities or opinion leaders with reputation higher than this person, but he or she also have a bunch of fans or followers who also maintain communication with the person in the middle, and they actually like communications with this person or make comments to it. So this person is somehow connects opinions provided by the high reputation people to the lower reputation people. And the interesting story about this, and that's actually the question that the problem that I was going to pose, is that besides structure of communication and besides intensity or density of communications between people on the social graph, it is interesting to capture emotions. And for example, I would be interested to know which communications in social making it possible to do now. Like in Facebook, create 6 emotions. Instead of doing just like, you can express more emotions. There are 6, like angry, sad, wow, love, etc. So you may be more precise evaluating the emotional context. And the thing is that in order to do so, you need to extract this information from the text. Apply machine learning in order to see which particular figures of speech, which particular words or combinations of words are actually expressing bad intent or good intent, express positive emotions or negative emotions. And in order to do so, there are different sources of information. There is information that can be extracted from these social networks. And by the way, the social networks, Steemit and Golos, are publicly available. So these networks are open for analysis. So you can potentially get this data and apply machine learning to it. And solving of this problem actually contributes to the first problem of reputation-based consensus or reputation study, because in order to calculate reputation properly, you may use not only explicit votes or likes or reputation ratings that I provide from one person to another. I may be just writing some posts saying that Eugenie is a great person, and that's not a direct vote, it's just a text. And the system should be able to extract the information about my saying that Eugenie is a great person, and so the reputation of Evgeny may grow just because of my mention of his name in the text. And that's another direction. So what do we have this time now? Are we all done?
If maybe you want to present some extra topic.
Okay. So let's ask the questions about this part first. So there are actually two goals, potentially. One goal is kind of social goal. The social goal is give society a tool or instrument to figure out right opinion leaders. Right, for example, just yesterday there was a meeting in the Academic Dialogue, maybe someone knows it. So there was a meeting like with strong argument between people who was saying like in few days there will some people taking everyone away from their houses and moving to the forest because all houses will be destroyed and high houses will be built in the place of existing houses. And the other people were saying like that's a nonsense, no one will take you away from your flats. And who is the right person to trust? So if there would be a way in community to figure out who is the right opinion leader, somehow track the reputation history of this particular person, that would be great value. That's one example. Another example, I think that many of you heard about the fake news problem. Like you get an article in the newspaper that all people will be just eliminated, or there will be a new law which makes some bad things, or some artist is dead, or whatever. Yeah, whatever. Or reptiloids will be appearing on our streets in 24 hours and bring us everyone to skies. So there is a very and sometimes these kinds of events actually affect the quality of life of the people, because if there are bad things said, if there are real bad things happening, that's important to know about bad things, because you can protect yourself from the bad things. But if the bad things are presented to the public just in order to attract attention to the news source, that of course that makes more attention to these news sources, and it provides more feedback on the commercial ads and makes commercial ad suppliers getting more benefits. But actually, these bad news and fake news are affecting quality of life of people. The people are upset, people are suffering heart attacks, people are suffering psychological problems because of so much being pumped into the social media just in order to attract attention, just so people are clicking some advertisement. So if there could be a way to somehow, that's another story. I have another presentation of this. If someone is interested, I can give you my card and send some links where this is discussed in more details. So there is to my understanding, there could be a very useful service where everyone can take particular news item, either URL or a text, and upload it or click it in the browser, and the browser will say this is 99% probability fake, or this is 99% probability true. So people can make decisions. That's one part of the story, and another part of the story is just make a business, make a successful market product, so it can be sold not to white people, but to people who actually are making money based on the reliable information, like financial brokers. So there is a thought that it might be useful. And another problem, actually related. So I take another 15 minutes, 10 to 15 minutes.
Suppose. Okay.
Okay. So just to have the complete picture of this. So, and another problem which is related to extraction of emotions and extraction of mentions of people in the text is the problem called language learning. So in order to be able to understand that I am mentioning someone in the text, in order to understand that software system capable to comprehend the natural language text can load the whole bunch of English grammar, in order to read the sequence of bytes and identify words and identify grammatical meaning for these words. That's noun, that's subject, that's name, that's action, that's person, and then the meaning can potentially be extracted. For Russian, there is no already thing like WordNet. Most state universities are working on this, but the work is not complete. For similar work, creating machine-readable grammar rules for the languages, this work is being created for some major European languages like Spanish, French, German, other languages. There is no way to do this work because the people in the countries don't have enough money to fund a lot of computational linguists. They don't have money to do a tremendous amount of research to build these grammars and put these grammars into the machine-readable format. So, and that's a big problem. So somehow the process of creating grammars for languages has to be automated. The other problem, and actually the other way to solve the problem of automatic comprehension of text is use machine learning, like neural networks, so they can learn from the texts themselves. But in order to do so, typically I use an approach which is called supervised machine learning, or text learning based on the markup training corpus. Like, there are training texts, and in each training text, specially educated people are marking parts of speech in this text. They are annotating text that, okay, so here is the phrase, here is the beginning of the phrase, here is the end of the phrase, and here is the noun, and here is the verb, and here is another noun, and these nouns are connected by this verb, and here is the time form of this particular verb. So all annotations are made manually, and then we have a bunch of these annotated text, and then we use machine learning, and this machine learning should be capable to learn how to actually derive these grammatical rules based on markup training corpus. But that's also a problem, because you need to create a lot of tests marked up the same way, and you need a lot of people especially dedicated to do markup of this training corpus. And all these people should be very careful, because if they make mistakes when doing markup, then the computer software, machine learning software will learn the wrong rules. So the problem that I'm now working in one of my projects is a problem of what we call unsupervised language learning. And unsupervised language learning is like you take a robot and you put the robot in the room, and you put a lot of books in this room, like you put You put all books written by Tolstoy, you put all books written by Dostoevsky, you put all books written by Pushkin, you also put all conversation logs from all messengers and all social networks, and you also put all these conversation and communication logs in this room, and then you just leave this computer system alone with all that stuff and let it figure out what are particular combinations of words, what are particular morphological variations of the words, which words are appearing with another words in the same with another words in the same context. So the system can draw some statistical dependencies and statistical relationships describing the dictionary of particular language and particular use cases of words in this language. So systems can somehow infer the grammatical rules in this language. And then in the end, computational linguists can see the structure inferred by the system, and then computational linguists can make adjustments, can make validation of this, saying like, okay, so that's true, that's right, that's not right, we need to remove this, and that's partially right, but let's do correction here, and then the system can account for this correction and use corrected rules in its further operations. And that's another story, and if someone is interested in this story, some more information can be given.
Do you have some unique access to data sets for this task?
Okay, so for each of these tasks, if someone is interested, I can get links or resources or give some comments of how to get to these resources. For each of these tasks, there is some way to get the data.
Mm-hmm.
So for that, so one of the data is data publicly available in Steam and Golos social networks, for one example. And for the last task called OpenCode, opencode.org, some public information that can be used to get training corporate and for Chinese.
Okay.
So
other questions?
I think we covered everything.
Do you know about the recurrent port networks approach to the language transition?
Which?
People kind of like recurrent port networks. It uses kind of different basic address from neural networks, and I've just written an article about that.
Okay, actually, there are many approaches to this problem. The last problem that I mentioned. So I have my own approach, let's say. And the people that and the project that I am taking, working on now, has different approach. And just today I have read another article, and they have another approach. So there is a problem. There are multiple approaches. It is so. If we are talking about making some magister or diploma work, whatever approach can be used to solve this problem, and if someone needs my recommendations and somehow help, this is what I have, but there are different approaches. Yes.
Can you revise the reports and propose clearly topics for master dissertations in one sentence?
Yes, yes. So all what has been said today, I can actually yes. So I can write 4 problem statements,
Okay.
and actually from these 4 statements could be some branches. So each of statements can be split further, but I can do just top level.
So we see that all problems presented are raised from practical things and
Yes.
can be applied to real processes and projects, and you can You can apply some particular problem and decide on it, make some solution. Okay, so thank you. Let's have a break, 3 minutes. Да, я еще представлю свои темы по теории изменений.
Да, Антон, сейчас давайте оставим.
Да, надо на доске написать. Я еще в этом.
Давайте. Я обычно нахожусь в территориальной гидросистеме, а вот здесь, да, пожалуйста, да, звоните, пишите, пожалуйста. А, да. Ну, смотрите, вот у нас сейчас вы сейчас свободны? Ну, я работаю. Нет, вот сейчас, да, просто это было. Значит, сейчас я звоню, значит, вы мне напишите письмо, я вам просто пошлю ссылку, то, что рассказываю, и там есть ссылка на материал. Вот, если можете с этого начать. Вот, мы по-другому сейчас пойдем поговорим, если еще возможно, что-то вот. Но мы говорим, как минимум, вы мне напишите письмо, я просто пошлю ссылку, Юра, привет. Слушай, мы закончили, то есть что, мы тебя ждем или мы двигаемся куда-нибудь, а ты к нам подтянешься потом? Что? Слушай, ну мы тогда, знаешь, что поскольку ребята живут не в Золотой долине, а ребята живут где-то в другом месте, мы тогда двигаемся в Тревелерс, в академию. Вот, соответственно, ты тогда в Тревелерсу приезжаешь, да? Вот, а вот студент твой, он, значит, тут уже ко мне подошел, мы его тогда с собой берем. Хорошо.
You said something funny there. Is it? Yes. No. No. You show this 4 problems, something like that.
By one sentence, the whole research topic. I want to publish it now. That should understand what is presented and what or topics.
Уважаемые коллеги, кому-нибудь еще нужны мои контакты или нет? Вам не предоставить? Да. Ну, если что, в любом случае можно связаться со мной через Евгения.
студентов своих разговоров. Вот здесь человек писал служебную, знаете, мы подумали, мы решили вам помочь.
Да, мы сейчас выходим.
Я решил 20 тысяч за вас. Все, что вы можете. Хотел сказать, сколько тебе воображения?
Для радости. Я вот разделяю.
Ну, это может быть да, в одном мальчике там трудно.
У нас это последний семестр освобождение активности
А потом по 45 минут.
Я написал письмо. Точнее, даже на вас
Ты, миссонетка, грязная. Сколько сил
Hey guys, let's start.
Нет.
Let's continue our seminar. Today I will present you a few topics which I will manage scientifically. These topics are connected to fundamental properties of data analytics algorithms and data presenting. The first topic is to to investigate the fundamentals of measurement theory. You know that there are 4 well-known scales or levels of measurement used in data analytics. Maybe somebody of you knows more than 4. This proof that there are only 6 scales. We have the first one is nominal, you know, nominal. When you can ask only the question which whether one element is equal to another. A is equal to B and nothing else. You can't measure the distance between 2 elements, the order, ratio, so on. Second is ordinal. Ordinal, when you can measure an order between 2 elements. So you can ask whether 2 elements are equal or greater than or less than. Next one is interval. So you can, in interval scales, you can compare 2 distance, 2 differences. So if you have 4 elements, A, B, C, and D, then you can answer if they have the same distance between them. A minus B is equal to C minus D. The example is dates.
Usually absolute value is used. Usually we are using absolute value.
Absolute value. Okay. I introduce some ideas. You can next class I will explain your the scales. Also 2 extra scales, and last one, absolute. Absolute, maybe absolute. Another name is ratio. When you have 0, and you can measure the relative between 2 elements. So all these measurements are presented in real numbers. You make some metric space, measure space, and introduce some distance between 2 elements. This function is from some object space to real numbers. But in applied statistics, there are well-known some spaces not presented by numbers. Can we change not numbers but some other space? Why? And the question is which properties we need to pose for this space properties. In that way, we can use this distance. So it's not usual distance. We measure two elements and can say they are far. One element is far from another, or close. We can provide such a space with, for example, 4 elements equal, close, maybe 3, close, middle, and far. And this space is ordered, and that is not, this space is not numbers. And the main question is, when we introduce such a metric, it's not a metric prime, for example, and how we can make such a proof that to revise data analytics, to revise machine learning algorithms. For example, what we need to do with KNN algorithm, random forest, neural networks, and so on. How we can revise these algorithms in order to use this measurement. So it's a bit mathematical logic and algebraic task. You need to dive into theory of algebraic systems and to prove some isomorphism, homomorphism between different systems, and prove that these algorithms really may use this metric space. So the benefits of this are the following. You are not restricted to real numbers, because real numbers are very, so at first it's a well-known structure. We almost know everything about real numbers. But for example, in functional analysis, there are some notions presented separable. I don't remember English notion for separable space. Yeah. Okay. Separable, and in Borel mathematics, in Borel spaces, you introduce measurable sets. So there are also unmeasurable sets, and how we can deal with that, we don't know, because real numbers is a structure which do not allow us to work with that. Okay, and really, when we make measurement of some real things in real world, we are forced to use real numbers, and that's why we have some collisions, for example, with mean of our marks, mean value for our marks, and sometimes we deal with measurements, such an operation that are prohibited to do because they are not real numbers. Okay. So I propose you to invent new measurement scheme. That's the first task. And second one, second task is to consider infinite spaces I give you one example. In losses, we consider it some feature space for a particular task of machine learning. For example, we have a set of objects in classification task. And these objects are presented in some vector space, maybe in some space. So for some particular object, we have x is I don't remember. Tuple of features. XM. And one of the well-known and popular approach to represent this object in some feature space. We make some function with a deep neural network, some sparse representation. And this function takes x and outputs in some vector space with dimension, for example, from 30 to 1,000 features. We don't really know which each feature means, but this space is built on the idea of some points of your initial set will be placed in similar points, will placed in similar vectors. And this one subset, second, and this sparse representation is well-known application in word to vec, job to vec, and so on. And what if we'll use not finite vector space, but infinite? So the idea is to use Hilbert infinite space to represent objects. Also, so we suppose that an object can be presented by infinite numbers of features. But real objects, what we can measure, we have only finite number of tools and measurements. Yeah? But we can put this object into an infinite space. And that's an initial idea. What things we can obtain from this idea? We can introduce a notion of inseparable space. So if this space is has finite dimension, then all subsets are measurable, and this space is separable. But if introduce infinite space, then we can use inseparable spaces. So that is going to represent some new effects.
Interesting.
Yeah. These effects are arising from quantum theory, because one of the approach to, for example, the fundamental of measurement lies in interaction with quantum world. When you make some measurement, you really interact with quantum world, and and in quantum world there are many notions of, well, mathematics, but there are really explain the term entanglement. Запутанность. Entanglement. When we have a coherent coherent rays, yeah, and separate coherent rays into, for example, two ways, and these particles, not particles, but waves are somehow connected. And when we make measurement on one, then we can answer what is on other, because they were coherent. And that's why we have an effect of teleportation of information, and that's that thing. So, and the one approach is to use inseparable Hilbert spaces to explain this phenomenon. And I suppose that is really connected to measurements we have in data analytics. So how we can deal with that? That is a research topic. Will be to model. First thing is to how we can model, how we can represent objects in infinite space. That's the first one. Then going deeply in quantum theory and making some new inventions. That is the second topic, and last one. Last one is simple idea. To use multiple representations for some particular how to say, image recognition, pattern recognition. For example, we have words. Words, for example, human. And now we deal with these words, with words represented in text, which is represented in computer by bytes. every character of this word, every character is a byte. Yeah, maybe in different coding stuff, different, but we deals with text as a sequence of zeros and ones. But human really represent words different way. It's some kind of sparse representations in our mind, but we use text very close, connected to our feelings, audio signals. We're hearing this word human with audio signal, and some images. So these letters are some are images, and the task is to the direction of this research is to connect audio, images with video information and text information. To improve quality of classification tasks. So in our challenge, we have some data set connected to this.
But isn't it just video? I mean, audio, image, and information, or I don't actually get the idea what should we do if we are participating in the research? Because for now, for me, when I hear like connect audio, images, and text, this is just video of humans speaking and
Subtitles.
Yeah, it's subtitles when it's saying it. So can you please clarify?
Okay. It's well known that when we use some extra information, for example, in classification tasks with text, when we use some audio information, it is an extra data source. So you have an extra information, and your algorithms, your classification will be better. But I propose you to mix all these sources and to post, for example, one simple task we would take and train your model in a way that it is done by human. So like a child, he learned from his experience some audio signals for each letter, for each word, but he learns from words, not letters. Letters are coming after words already learned. And only after that we learn text representation. So first are from audio and some events which are connected to feelings and that way. So the first, I want to develop this direction in our laboratory. And first thing is to crawl to make data sets and make to decide on one task, one classification task when we have audio signals for some images and video, and we try to pose it on some small ontology and use it for some basic classifications, like child do.
But when somebody is child, he has not only the correspondence between text, audio, image, and so on, he also has the connection between that different representations of the one subject. He has also the associations with other subjects and so on, with other entities, so on, and how could we handle that stuff in the way you described?
We can model. We can model and produce such a video and audio content.
I mean, how we could handle with those associations while we have the legal ontology. Because when ontology is big, it's quite clear how it is.
We also need to infer this ontology from our events. We start from small ontology, and then we infer it by, for example, for using association rules to infer some connections between objects recognized from the space. Have you answered?
You gave me some ideas.
So that's all. To make long story short, first to invent new measurement scale and to make proof of the ability to use this measurement scale in data analytics algorithms. Second one is to represent in infinite space classification task. And third one is to build a data set for small classification task, which is using mix of data sources.
Can you provide a short description?
Yeah, I will provide this in chats and both mine and Anton's work.
This one was cool. This one, the last one looks very promising.
Second one's cool.
The second one is unclear, and not only for me.
Yes, so just very good. It would be very, very nice because we'll have an experience in this challenge.
Yeah, I see that maybe we can use this data set.
Actually, that data set
Is in law.
Meaningless. What? Meaningless.
It's not meaningless. It has privacy, copyrights, and so many stuff.
We can use ideas derived from this.
actually there are some. The data is somehow performed after receiving in the raw formats, and so it's quite difficult to make the correspondence between text and audio, for example, because there is no the usual audio. There are only features, and it is much less info than we would have in the raw format. So I don't think it would be very convenient and very.
But I guess it's so the guys who are interested in this.
I saw one presentation on TED, and one researcher presented that he recorded for 1.5 years of his child's being in his home, and yeah,
1.5
he
years.
collected audio, all audio, video information about his child growing and learning how to say words in water, and
How the child learn to speak in general.
yeah, to speak in general, and then see he showed how he learns the word water, and that was look like then water, and then water.
Very single neural network processing.
Yeah, very similar. I'll provide it.
It would be great. It is really looks like awesome research.
So, who you need to have brain?
Yes.
10 minutes.
And after that, after that,
After that, we'll talk about determining tools. So for a seminar, it is ended. Okay.
Yeah.